this video, we're going to discuss angles in standard position. We'll review the basic Cartesian coordinate system. We'll look at how to put angles in standard position, and we'll also learn about coterminal angles. Here's the basic Cartesian coordinate system. We have our x-axis and our y-axis, and where they meet is a 90-degree angle. And we have a name for the spot where they intersect, the origin. We can also divide up this Cartesian plane into 4 quadrants. We start off with quadrant 1 in the upper right-hand corner, and then go counterclockwise to quadrants 2, 3, and 4. And you can see that we use Roman numerals when talking about quadrants. Mathematicians prefer to put things in standard forms, so when we're talking about, for instance, a specific angle, we all know what we're talking about. So for instance, if I have an angle, in order to put it in standard position, I'm going to do 2 things. First off, I'm going to line up the vertex of my angle. Remember, that's where the 2 rays meet. And we'll line that vertex up with the origin of the coordinate plane. And there's another thing we need to do. That first side, that first ray, will line up along the positive x-axis. So once we've lined up the vertex and lined up that starting ray, then we have our angle in standard position. We're going to add a bit of vocabulary here. That first side is also called our initial side. The second ray is called the terminal side. That's where the angle terminates. And if I mark an angle such as this is a positive rotation. It moves counterclockwise. If we have an angle that is between 0 and 360 degrees, we can tell what quadrant it will land in. This first quadrant would have angles between 0 and 90 degrees. It's what we've known as an acute angle. If we keep rotating, we'd come up with an angle of 90 degrees, or what we know as a right angle, and that lines up with the positive y-axis. If we continue to rotate, then we end up in quadrant 2, where the angle would be between 90 and 180 degrees, and this is what we've known as an obtuse angle. If we keep up our rotations, we end up with 180 degrees, or a straight angle, and this would be lined up with the negative x-axis. Now we don't have to limit ourselves to acute angles and even obtuse angles. We can continue this rotation, and if you have an angle between 180 and 270 degrees, you'll be in quadrant 3. The negative y-axis would represent an angle of 270 degrees. And if we keep up our rotation, quadrant 4, those angles will be between 270 degrees and 360 degrees. Well, if we look at that angle, it seems like there's another way we could talk about that. Instead of a positive rotation going all the way past 270 degrees, it seems that we could also talk about the smaller angle. And we can talk about angles such as this, however, they're rotating in the opposite direction of what we considered a positive angle. So a negative rotation is when we move in a clockwise rotation. Counterclockwise is positive, and clockwise is negative rotation. That would be a negative angle. For instance, this angle looks about to be negative 52 degrees. What's interesting though, if I take away those little arcs showing me which way I've rotated, I have a hard time telling, is this a negative angle or is this a large positive angle? Well, this is when we start talking about coterminal angles. Coterminal angles are 2 different angles or 2 different rotations that have the same terminal side. Let's take an example. Let's look at 32 degrees. It's positive 32 degrees, so we're going to rotate it counterclockwise. It's an acute angle, so we would expect it to be in quadrant 1. However, what happens if I wanted to graph, say, an angle of 392 degrees? Well, that's odd, because really we know that there's 360 degrees in this circle. Well, first let's graph 360 degrees. That is at the initial side and goes all the way back around to that positive x-axis again. We don't want to graph 360 degrees, we want to graph 392 degrees. Well, if I've already graphed 360 degrees and we subtract that from our angle of 392, we end up with 32 degrees. So if I graph 32 degrees, and if I graph 392 degrees, the terminal sides line up. That is, they are coterminal angles. They share the same initial side and the same terminal side. So 32 degrees plus a complete rotation of 360 degrees is equal to 392 degrees, its coterminal angle. Well, I don't have to limit myself to just one rotation. I could take my 392 degrees and add another rotation to that, and then I would end up with an angle of 572 degrees. And again, it would be coterminal with 392 degrees and 32 degrees. You cannot tell just by looking at the terminal side which of these three angles the original angle was. Well, I've added 360 degrees. What happens if I subtract 360 degrees? That is, instead of continuing 360 degrees counterclockwise, what happens if I go backwards, if I go clockwise from 32 degrees? So if I take 32 degrees and then rotate it clockwise, that would be a negative rotation of 360 degrees. Well, that's the same thing as taking 32 degrees and subtracting from it 360 degrees, and I would end up with an angle of negative 328 degrees. Again, I wouldn't have to stop there. If I took my angle of negative 328 degrees and subtracted from it another 360 degrees, that is, took away another complete rotation, then I would end up with an angle of negative 688 degrees. So now we have found 5 different angles that are all coterminal: 32, 392, 572, and negative 328 and negative 688. If I take away those rotations and I show you this angle, you can't tell me which one of those 5 angles caused this angle. And of course, we're not limited to the rotations that we have. We could have continued to add 360 degrees or subtract 360 degrees to our heart's content. One type of question you might be asked on your homework or an exam is, what is the first positive coterminal angle with a particular angle? So let's look at an example. If I say, what's the first positive angle coterminal with 96 degrees? What we're going to do is add 360 degrees to our 96 degrees and come up with our answer of 456 degrees. If then we're asked what's the first negative angle coterminal with 96 degrees, instead of adding 360 degrees, we're going to subtract 360 degrees from our 96, and that gives us an angle of negative 264 degrees. So this is how you find angles that are coterminal with a particular angle. You either add 360 degrees or subtract 360 degrees. Another kind of question you can be asked is one like this. Given an angle, what quadrant does the terminal side lie in? So for instance, if we take this example of 920 degrees, and we want to know which quadrant that terminal side ends up in, well, 920 degrees is not one we know right off the bat, so what we want to do is subtract from this 360 degrees until we can get an angle between 0 and 360 degrees. So if I take my 920 and subtract from it 360 degrees, I end up with, well, 560 degrees, which is still not between 0 and 360. So if I subtract out again another complete rotation of 360 degrees, well, then I end up with 200 degrees, and that is between 0 and 360 degrees. In fact, I know that an angle of 200 degrees ends up with its terminal side in quadrant 3. And how do I know that? Well, if I remember from the beginning of the lecture, when we were talking about angles between 0 and 360 degrees, we found that in quadrant 3, angles are between 180 degrees and 270 degrees. Let's take one more example. Let's look at an angle of negative 1,100 degrees. Well, in this case, instead of subtracting complete rotations, we're going to be adding complete rotations. We want an angle between 0 and positive 360 degrees. So we need to add complete rotations to this negative number until we get a positive result between 0 and 360. And in this case, we're going to need to add 4 complete rotations in order for this to happen. So if we add 360 degrees 4 times, we end up with an angle of 340 degrees. An angle of 340 degrees has a terminal side in quadrant 4. Again, if we look at a slide from the beginning of the class, we see that quadrant 4 has angles between 270 degrees and 360 degrees. And now we have gone through angles in standard position. We know how to talk about the basic Cartesian coordinate system, we know how to put angles in standard position, and we can find coterminal angles.